Now we discuss probability models. Probability models describe mathematically the outcome of a random processes. A probability model consists of two parts. The first one is called a sample space. The second part is a probability for each possible event in the sample space. So S, sample space, then a probability for each possible event. The sample space is a set or a list of all possible outcomes of a random process. An event is a subset of the sample space. That means you list for all the possible outcomes, then any event can be any combination, any subset of this possible outcomes. We have an example to show this. The probability model for a coin toss is the first one. We need to have the sample space, so S. The S gives us the all possible outcomes. We toss only one coin, so we have only two possibilities. The first one is head, the second one is tail. So the sample space S equals head and tail. So we list all the possibilities of the outcome. The next one is for each of these outcomes in the sample space. In this case, we have head or tail. We have two. We need to list the corresponding probability. We know from experience the probability for the outcome to be a head is 0.5. And the probability for the outcome to be a tail is also 0.5. So these three, the first part, sample space, the second one, list of all the probability for all the possible outcomes. This gives us the probability model. So we have these three, give us the two parts, give us the probability model. Now the second example, we try to find the probability model for a two coin toss event. We toss two coins. So when we try to find the probability model, again, we need to list the sample space and the corresponding probabilities. Now we need to distinguish how we toss these two coins. The first one is order. That means we are going to toss this coin one by one. So we toss the first one first. So coin one first, then we turn the second. The first one, we may get head, we may get tail. The second one, we may get head, and we may get tail. So what is the possible outcome for this event, which is order? So we can have the first one is head. So that's sample space is the first one is head, and the second one is head. So first one is head, the second one is head. So that is one possibility. Then the second one is the first one is still head, but the second one is tail. So that is the second probability. Definitely the next one is the first one is tail, the second one is head. So this. Then the last one will be both are tails. So this is the sample space for this ordered two coin toss. And we need to find the probabilities. So the probabilities for this one is, and later time we are going to learn how to calculate this, but we can guess here. So the guess is good enough. So that one will be a quarter. And for this one is also a quarter. And for this one here is also a quarter, so this one is also a quarter. These two parts give us the probability model. And the first one is the sample space. We need to list all the possible outcomes. And in the second part, we need to list the possible, corresponding possible probabilities. So that is the first one. Now we consider if the toss is, the two coin toss is non-ordered. That means we toss them together. So what do we have? Okay, the first one still can be head and tail, 50%. The second one still head and tail. Now this sample space will be, because we don't know which one is the first, which one is the second, but we only know we have two head. So this one head will be equals to we have two head, or we have two tails, or the third possibility that we have one head, one tail. Because this toss is a non-order, so we don't know which one is the first, which one is the second. So we only know one is head, one is tail. Okay, so that's it. We have three possibilities. So this is the sample space for the non-order two-corner toss event. Now we need to find the probability. And the probability for this, we may guess as before, it's 1/3, 1/3, and 1/3. Unfortunately, this is not correct. Again, later time, we are going to find out that this one is not good, this one is not good, this one is not good too. So actually, this one is a quarter, and this one is a quarter, and this one will be 2 quarters, which is half. So this gives us the probability model for two-corner toss is non-order. Next one, we are going to discuss some simple probability rules. The first one we are going to discuss is addition rule for disjoint event. First one we know a fact. The probabilities range from 0 to 1 because probability is the number of occurrence divided by the total number. So if there's no chance of that event, then the number equals 0. The 0 divided by some non-zero value equals 0. That probability equals 0. The maximum probability equals 1. That means all the possibilities belongs to that event. So that equals 1. So any event A, the probability, we write like in this, probability, parentheses inside A, that means the probability for event A is greater or equal to 0 and less than or equal to 1. In each trial, because some outcome must occur, no matter what kind of outcomes. So the sum of the probabilities for all possible outcomes give us the sample space, must be exactly equal to 1. So that means the probability for the sample space will be equal to 1. So we need to keep this in mind. We are going to use this factor many times. So for for the sample space, the probability is equal to 100%. The next one is disjoint concept. We call two events A and B are disjoint if they have no outcomes in common and can never happen together. If we use a Venn diagram, we draw this like this here. So this S means the sample space. And this is event A, and this is event B. We can see both event A and event B have no overlap. So that means some outcomes can never happen together. In this case, we call event A and event B are disjoint. In this case here, so event A is this, event B is this. They have overlap. And this part is called A and B. That means outcome here belongs to A, event A, and also belongs to event B. So this is not A, and in this case, A and B are not disjoint. The first simple rule is addition rule. Addition rule for disjoint event. in this one. It says the probability for A or B. This is in a word. Sometimes we prefer use a mathematics representation. This is or. So probability for A or B will be equal to the probability of A plus the probability of B. For example, in the class, you take an exam. Either you pass or fail. Event pass and event fail are destroyed because you cannot pass and fail at the same time. And in this case, we have only two events, pass and fail. So the probability for you to pass or fail equals the probability for you to pass and the probability for you to fail, then will be equal to 1. So pass and fail are destroyed. Another concept is called the complement rule. The complement of any event A is the event that A does not occur. We write this one as A raised to the, looks like a power, it's not power. A to the C. It's called A complement. The complement rule states that the probability of an event not occurring is 1 minus the probability that it does occur. So the formula is the probability for A to not occur equals that's A complement. And that equals 1 minus the probability for A to occur. Here is the Venn diagram. Suppose this is the sample space, and this part is the event A. Then A to the C means A complement is all the event that A does not occur. So this is the whole sample space, and this is A. Then all the remaining part will be defined as A to the C. We have an example. The first one. When we toss the coin, there's only one, so we have head or tail. So tail complement means not tail. Not tail, because in this sample space has only two, head and tail. So not tail means head. So tail complement equals head. Then the probability of tail complement means the probability of head. Tail C is head. So P this equals P this. And P head equals 50%. Then P tail complement is also 50%. Another example is if the score is greater or larger than 80, the probability for this is 60%. Then the probability for the score to be less than 80 will be equals 0.4. Because no matter what your score is, you must be either greater or larger than 80 or less than 80. Either way. So this is one is A, another one is A complement. And these two form the complete sample space. So that means the probability for this one and the probability of this one add up together must be equal to 1. So P not A plus PA must be equal to 1. So this and this must be equal to 1. So this is a complement rule. we are going to use this one in some example. The next rule is finite number of outcomes. Finite sample spaces deal with discrete data. For example, your test score is, if I give you only integers, either 0, 1, 2, 3, 4, all the way up to 100. We do not give you 80.934 or something. Yeah? The data that can only take a limited number of values. So the score is not a complete real, it is only an integer. So this is a finite sample space. The individual outcomes of a random phenomena are always disjoint. In this score example, if you get 80, then you cannot get 81. If you get 81, you cannot get 90. So all these outcomes are disjoint. Additional rule here is the probability of any event is the sum of the probabilities of outcomes making up that event. For example, if I randomly, completely randomly give you a score from 0 to 100, then what is the probability for you to get 100? Because I give you from 0 to 100, we have 101 possibilities. From 0 to 100, that means the probability for each one is 1 over 1. 1 over 1, because we have from 0 to 100, that is 101 numbers. So each number has a probability of 1 over 1. So what is the probability for you to get 90 and above? So that 90 and above, that means A. If you get A, the event A, to get A, the probabilities, the outcomes is 90, 91, 92, all the way to 100. So we have 11 outcomes. These 11 outcomes form the event of you get A. So what is the probability that you get A? That is the sum of all the probabilities of the outcomes making up the event. So the probability for you to get A is 11. So each one is 1 over 1. Then we have 11 possibility outcomes. So that probability will be 11 over 1 over 1. It is less than, it's more than 10%. So that is the example. Okay, now we have another little bit more complicated example. We are talking about candies. If you draw an candy at a random from a bag, the candy will have one of the 6 colors. We assume the 6 colors are brown, red, yellow, green, orange, and blue. And we have done a test, and we found out that the probability for you to get a brown randomly is 0.3, yes, 30%. And for you to get a red is 20%, yellow 20%, green 10%, orange is 10%. The question is, what is the probability for you to get a blue? We already assume we have only these 6 colors. We know the probabilities for all other 5. So what's the probability for this one? We don't need to do the experiment. We can just calculate. The probability for the candy to be a blue is 1 minus this part. Everything is in the square parentheses is called a blue complement. Means the probability to be blue equals 1 minus the probability to be not blue. So not blue means brown or red or yellow or green or orange. Now all these 5 are disjoint. So the total probability for this, the probability for blue complement will be equal to this one here, because all these 5 events are disjoint. So the total probability will be equal to the sum of all the individual probability. So that means this one equals 0.3, this one is 0.2, this one is 0.2, 0.1, and this one is 0.1. All these 5 numbers add up together equals 0.9. And 1 minus 0.9 equals 0.1. So that is the probability for the candidate to be a blue. So this problem is solved from the complement rule. The next one is asks what's the probability that a random candy is either red, yellow, or orange. So either red, yellow, or orange. This is a finite number of outcomes. This event has 3 outcomes. The first one is red, the second one is yellow, the next one is orange. From here, the probability of any event here, this one, red, yellow, or orange, is the sum of the probabilities of outcomes making up this event. This event is made up with red, yellow, and orange. So it is the sum of all the probability. So the probability for this red, yellow, or orange is P red plus P yellow plus P orange. And red equals 20%, yellow equals 20%, and orange equals 10%. Add up together equals 50%. In the homework feedback, I mentioned, emphasized, when you do all these problems, you need to give us the appropriate formulas. I cannot accept only the numbers. You give me only this number, only this number is 0.1 or something. You won't get credit for this. You need to give us, follow the steps like here, give us all the formulas to make sure you show me you understand all the principles. The next topic we are going to discuss is equally likely outcome. From our experience, we have 2 ways to assign probabilities. Empirically, from our knowledge of numerous similar past events, for example, the probability for to be ahead when you toss a coin is 50%. That is from our knowledge. Or theoretically, from our understanding of the phenomena and the symmetries in the problem. If a random phenomenon has k equally likely possible outcomes, then each individual outcome has a probability of 1 over k. That is a probability for equally likely outcomes. For any given event A, the probability of event A equals the count of outcomes in A divided by the count of outcomes in S. What is S? Sample space. Right? Now we have an example here. We toss 2 dice. We know the dice has 6 sides. Each side has a 1 dot, 2 dot, 3, 4, 5, or 6. We toss these 2 dice and we record the number of dots. All the possible outcomes are called the sample space. The sample space are drawn here. The first dice is 1 point, second dice is 1 point. The first dice is 1, the second is 2, the first one is 1, second is 3, and so on. Right? The first one is 1, the second one is 6. And also the last one is the first one is 6, the last one is the second one is 6. So we have 6 times 6 we have a totally 36 possible outcomes. Right? These outcomes not only possible, and actually they are equally likely. So that means the possibility for this to occur equals 1/36. They are equally likely outcomes. In this case, we have 36 equally likely possible outcomes, and the total has 1, and so each individual outcome has a probability of 1/36. Right? So this 1/36 is calculated from here, 1/k. So 1/k equals 1/36. And what the question, another question is, what is the probability we roll 2 dice and the sum equals 5? And in this event, the 2 dice, the sum equal to 5. And if you look at this sample space, we have this one. The first one is 4, the second is 1. So add up together equals 5. Or the first one is 3, the second one is 2, add up together again equals 5. And next one is 2, 3, and the last one is 1 and 4. All these 4 outcomes give us the sum of 5. So this forms the event A. And we don't have any others. Or others like this one, 6 and 4, that's 10. Does not belong to event A. So in event A, we have only these 4 outcomes. So what is the probability for event A to occur? Right? The total number of outcomes equals 4, 1, 2, 3, 4. Okay, the total count of outcomes in the sample space equals 36. So that is 4/36 and equals 11%. We mentioned probability is very interesting, and sometimes it's very hard. It's not easy to see clearly, but as we said, it's very useful. We need to have a better understanding of this. Actually, in our daily life, there are a lot of situations, possibility will exist. So now next example is this one. So some of you may already play this in the casino. This is called roulette, and I assume you already know how to play this. The point is here, there's some numbers. The payout is defined by 36 over n minus 1. N is the number of squares the player is betting on. For example, if you bet only 1 square somewhere here, then n equals 1, so 36 minus 36 over 1 equals 36. Then minus 1 equals 35, so the payout equals 35. Payout means is the payment in addition to the initial bet. So if you bet this one here, n equals 1, n equals 1 here, then if you win this, then you get 36. Now the point is, if this one wheel has only 36 numbers from 1 to 36, then theoretically you won't win, you won't lose. Okay? And actually the casino will lose because they need to provide the space, okay, free drinks or anything. So they won't do this. So why they are going to win? Okay? The trick is here. In this wheel, we do not have only 36 numbers. Actually, we have 38. We have 1 0 here, we have another one, we have a 0 here, and we have another one, a double 0 here. So actually we have a 38, hopefully equally likely outcomes. But they only give you, if you win, they only give you 36 back. Right? So that is the edge. You have a 38 equally likely outcomes, but if you win, you only get a 36 back. The difference or the percentage is called the horse average or the horse edge or anything is expected value. So theoretically, if the casino can open for infinite time, they always win. They won't lose. Okay? We have some concept numbers here. The hold is the average percentage of money originally brought to the table that the player loses before he leaves. The average win hold for double zero wheels, double zero here, we have 2 zeros, is between 21 to 30%. That means on average, each player will lose like 20 to 30%, then he left. And actually, on average, if you play once, you are going to lose 5.26% of your money. So that is called the horse edge. And this number can be calculated from the design of this wheel. If you are interested, there are a lot of some articles on the website, you can find details. But anyway, this is a perfect application of probability. Okay, next we'll discuss another rule. It's called the multiplication rule for independent event. Recall we discussed disjoint event before. Now we discuss independent event. These two concepts looks like very close, but actually they are different. We need to make sure everybody understands the difference between these two. Otherwise, you are going to have trouble doing the homework or doing solve problems. Recall that two events A and B are disjoint, means they do not share the same identical outcomes. For example, if you pass the test or you fail the test, you cannot pass and fail at the same time. Two events A and B are independent, means one occurs does not change the probability that the other occurs. One example is, for example, you pass the test and I pass the test. These two events, one is A, another is B, usually is independent. Because no matter you pass the test or not, it does not affect my probability pass or fail the test. At least in our class. Another one is the Powerball. If you hit the jackpot, you hit the jackpot and I hit the jackpot. These two are event A and B. These two are independent? Yes, they are independent. The reason is if you can hit the jackpot, I can hit also. So we won't affect each other. But how about this? If there's only one, there's only one prize. These two are still independent? No, because there's only one winner. If you win it, then I cannot. If I win it, then you cannot. So these two are not independent. We can have other more examples of independent event. Anyway, independent event means the probability for one to occur does not affect the possibility for the other to occur. For disjoint event, we have the addition. The probability disjoint means PA or B equals PA plus PB. This one. For independent event, we have a multiplication. So we need to distinguish between these two. For disjoint, we have an addition. For independent, we have a multiplication. If A and B are independent, then the probability for A and B. Here is A or B. This is or. This is and. The probability for event A and B occur at the same time. And we know A and B cannot occur at the same time in this example, but here they can. Because they are independent, they can occur at the same time. Equals the probability for A to occur times the probability for B to occur. Right? So this is the multiplication rule for independent events. Keep in mind, only if A and B are independent, this multiplication rule all works. Otherwise, it won't. Later time, we are going to learn in general how this multiplication rule works. Okay? Example, 2 consecutive coin tosses. The first one is tail, the second one is tail. What is the probability for these two to be tail at the same time? Because they are independent, because we have 2 different coins, they are independent. So the first one, and again, keep in mind this is and, these 2 occur. This is first tail is this event A, the second one is B. So A and B, so A and B equals this is A, PA times PB here. And we know PA equals 50% and PB also equals 50%. So 50 times 50% equals 25%. We already know this number from when we list the probability model for the coin toss. We already know 50, a quarter probability. The Venn diagram is event A and event B. You see, they are independent, so they can occur at the same time. So definitely these 2 are not disjoint, but they are still can be independent. The probability for A and B means this part, this white part is A and B. They occur at the same time. The probability for this one, A and B equals the probability for A multiply the probability for B. Okay, next we are going to discuss example. We are going to use a lot of rules we just discussed in this unit, and we try to solve this problem. Right? The problem is a couple wants 3 children. What are the arrangement of boys and girls? We assume that the probability that a baby is a boy or a girl is the same, 50%. In real life, maybe not, but we assume here each one is 50%. First one, what is the sample space? This is the probability model. The first part is the sample space. The sample space, recall that is all the possible outcomes. We have 3 babies. We can only have boys and girls. So the first one is boy, the second one is boy, the third one is boy. So that is possible. Or the first one is boy, the second one is boy, the third one is girl. Well, that is also possible. Or the first one is boy, the second one is girl, the third one is boy. So this is possible, and we can see all the possible arrangement are listed here. So we know 1, 2, 3, 4, 5, 6, 7, 8. And the last one is all 3 are girls. So the size of the sample space equals 8. That is the all and only possible outcomes we may have in this example. This is the sample space. For the probability model, we need to also list the corresponding probabilities for all these outcomes. All 8 outcomes in the sample space are equally likely. So k equals, here k equals 8. Because 1, 2, 3, 4, 5, 6, 7, 8. So the probability for each equals 1 over k, which equals 1 over 8. Right? So that's it. That is from here and here, this is the probability model. This is the probability model. Right? You may ask, how do we know they are equally likely? For example, how do we know this probability for we have 3 boys equals 8? Right? Now we know from the problem we said the first one to be a boy or girl, the second one to be a boy or girl, the third one to be a boy or girl. All these are independent. Right? So each birth is independent of the next. So we can use the multiplication rule we just discussed for this independent event. Then this event is B, boy, boy, boy. So in this case, we are going to have like event A, event B, and event C. So that probability will be equals probability for event A times probability for event B, and times the probability for event C. And we know the boy probability equals half, boy probability equals half, boy probability equals half. So half, half, half multiplied together equals 1/8. So that means the probability for this one equals 1/8. And any of this combination will be equals 1/8. For example, the girls, okay, half, 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 and the girls half, boys half, and girls half. All these are half times half times half equals 1/8. So we can simply say they are equally likely, and the k equals 8. So for each probability equals 1 over k, which equals 1 over 8. Okay? Now we consider this problem with from another view. A couple wants 3 children, just like this. What are the numbers of girls? Here, the number of girls. This x is the numbers of girls they could have. The same genetic laws apply in these boys and girls. Each one has a 50% chance. We can use the probabilities above and the addition rule for disjoint event to calculate the probability for x. First one, the sample space. The sample space, the variable is x, which is the number of girls. So how many girls we can have? That means the possible outcomes for x. We can have all boys. That means the number of girls equals 0. So that is good. That is here. Or we can have only 1 girl, or we can have only 2 girls and 3 girls. All are girls. So the sample space is as 0, 1, 2, 3. This example you cannot write boy or girl because the variable is x, means the number of girls. We can only list the possible outcome for x. X can only be 0 or 1 or 2 or 3. It's not boy or girl. So we need to make sure here is a number. So the sample space equals 0, 1, 2, 3. So the size equals 4. Now the question is, we have the k equals 4. K here equals 4. Are they equally likely event? That means the probability for you have a 0 girl equals 1/4. For 1 girl equals 1/4, 2 girls, quarter, 3 girls equals quarter. Is this true or not? Right? Let's see. If x equals 0 means we have 0 girls, means we have all 3 boys. Oh, we know that. All 3 boys, there's only one situation here, which is this. So we know the probability for this to happen is 1/8. So probability for x equals 0 equals 1/8. Next one is how about x equals 1? X equals 1 means we have only 1 girl. So we can see the girl can be the 3rd one, the girl can be the 2nd one, the girl can be the 1st one. These are the only 3 possibilities that we have only 1 girl. This one we have no girl, this one we have 2 girls, and this one we have 3 girls. So this here, this and this and this. We know all these 8 are equally likely. So from the addition rule, the event is x equals 1. It will be the sum of all the probabilities that making up the event. BB girl, boy boy girl, and BGB and GBB. So the probability for x equals 1 will be equals this. We know here equals 1/8. This one equals 1/8. This one equals 1/8. So 1/8, 1/8, 1/8 equals 3/8. So that is x equals 1. How about the x equals 2? X equals 2, the same thing. X equals 2, so this one, and this one. So again, equals 3/8. The last one is x equals 3. The probability for x equals 3 is this is the only possibility. So it equals 1 or 8. Now, what is the probability model? Again, we recall the probability model means we need to list all the possible outcomes, which is here, and also we need to list all the possible, all the probabilities for the outcome. And for 0, the probability equals 1 is. For 1, probability equals 3 is. For 2, the probability equals 3 is. And for 3, the probability equals 1 is. So this is the sample space. This is the corresponding probabilities, and this completes, these two complete the probability model. When we calculate all these probabilities, we need to use the rules, addition rule, complement rule, multiplication rule to calculate this.